Hello everyone. Today we are going to learn about some data science concepts or the data science concepts. They might help you with your Viva questions. So, we are going to learn about data cleaning, handling errors, noise, and missing values. Then, machine learning concepts. In machine learning, we are going to learn about the core concepts, regression, and overfitting. Then, we are going to learn about deep learning, neural networks, CNNs, RNNs, and more. Then, in Python and data structures, we are going to learn about lists, tuple dictionaries, and sets. So the first section A deals with data cleaning, the foundation of reliable analysis. We explore techniques for handling missing data, removing noise, and ensuring data consistency. Uh, then the first part in data cleaning, the question we have is, when merging datasets with different measurement systems, ensuring what between units is crucial. So it is consistency. Then in data clearing, what stresses that analysis quality depends on input data. So in data cleaning, garbage in and garbage out stresses that analysis quality depends on input data. Then what are the systemic problems introduced during the data cleaning process that can be corrected? So errors or noise are systematic problems introducing during the data cleaning process that can be corrected. Then we have irrecoverable information loss during acquisition. Example, power outage is a n dash. So it is a random error. Then we have replacing missing data with the mean of existing value is called, so it is called mean imputation. Then we have, in data cleaning only, we have another subset of questions, that is, filling missing values via linear regression or curve fitting is known as what? So it is known as regression imputation. Then we have always preserve both the what data and the cleaned data set. So we have to always preserve the original data and the cleaned data set. Okay. Then we have the question as converting John Smith to Smith John is an example of, so it is an example of data transformation. Then we have outlier detection is often used as a check for what? So it is used as a check for data quality. Then we have functions like Unicode help remove inconsistent character during which repair? So it helps remove inconsistent character during encoding repair. Then now in section B we are going to learn about machine learning concepts. What are we going to learn here? Key concepts in predictive modeling, including feature engineering, model evaluation, and common pitfalls like overfitting. Now we are in machine learning concepts and we have first set of questions. So transforming raw variables into more informative ones is called what? So it is called feature engineering. Then predicting a numeric value such as salary is an example of, so predicting a numeric value is an example of regression. Okay. Then we have a model that fits training data perfectly but fails on new data suffers from what? So it suffers from overfitting. Dropout and weight penalties are example of which methods? So dropout and weight penalties are example of regularization method. Then training multiple diverse models to improve accuracy is known as what? So it is known as ensemble learning. Then we have another question and the last question of the first set of questions in ML concepts, and that is a simple reference model for comparison is called a which model? So it's called a baseline model. Then we have machine learning concepts part 2. Independent unchanging data samples are described as which data? So these are described as static data. Then parameters tuned before training are called what? So these are called hyperparameters. Comparing two versions statistically to see which perform better is A or B testing. Normalization typically rescales numeric features to the range 0, 1 or -1, 1. The difference between train and test performance measures model generalization gap. Bias sampling in data collection can cause what? So it can cause selection bias. Then we move to section C, and section C deals with deep learning. exploring neural networks from basic architecture to advanced models like CNNs, RNNs, and GANs. So our first set of questions in deep learning. First question: a model trained once and not updated further is called a static model. Then a model that continually retrains with new data is called a dynamic or online model. Like GitHub, we can online just directly go and correct or commit something, and hence it becomes an online model or a dynamic model. Okay, and the programs that we are running on our local systems are called static programs. Okay, then we are going to discuss about the loss function measuring divergence between predicted and true probabilities is cross entropy. Deep learning is a specialized subset of machine learning. Neural networks are universal of what functions? So neural networks are universal approximators of function. A network with more than one hidden layer is termed as a deep NN. Now we are to the second part of set of questions. So each layer's output become the next layer's input. CNNs are mainly used for which classification? So they are used for image or spatial classification. RNNs handle data with strong or dash dependencies. So RNNs handle data with strong temporal dependencies. LSTM is an improved version of a dash network. So LSTM is an improved version of a recurrent network. In a GAN, the second model acts as a what? Distinguishing real and fake data discriminator. Reusing a pre-trained model for a related task is called dash learning. So it's called transfer learning. Now we have third set of questions in deep learning. The wide part of wide and deep model helps dash specific examples. It helps memorize specific examples. The deep part captures more dash features. So the deep part captures more abstract or latent features. Linear classifiers combine inputs with dash and dash to perform predictions. So linear classifiers combine input with weights and bias to form predictions. Then we have the question: activation functions introduce dash into neural models, so non-linearity. Then adding neurons or hidden layers increases model capacity. Transfer learning leverages dash features learned from prior tasks, so generalized. Now we have section D, Python data structures. In Python data structures, we have essential knowledge for efficient coding covering lists, tuples, dictionaries, sets, and specialized structures. Lists are ordered and what, meaning they can be changed. So lists are mutable. Tuples differ from lists because they are immutable. Dictionaries store data as key value pairs. Sets contain only unique elements. DQ allows fast operations at both ends. Counter is a subclass of dict that tallies occurrences. A frozen set is a set that is immutable. The heap queue module implements a dash queue. Heap queue implements a priority queue. Then we have in a max heap, each parent node's value is less than equal to its children. Converting a list into heap order is called heapify. And that's it for today. And we are up with today's questions. Thank you for watching.